Thanks a lot, Peter, for the introduction. 50 minutes there should be fine. I try to do the best, and especially try to reserve some room for questions afterwards. So this talk is about the 5G NORMA architecture, and so it will focus on selected concepts that we try to basically implement into or try to consider when designing the architecture, and also I will also give a brief view on some selected security concepts that we are working on, but that specifically focus on certain issues that relate again to the 5G NORMA network architecture. So starting with a brief motivation, I guess you have seen this in recent days before, in recent talks before. So what we are actually aiming at, and actually the project design happened before this NGMN paper was released. In that sense, the consortium of 5G NORMA was ahead of what NGMN in the end stated in terms of requirements. Is of course now here the issue of building a mobile network architecture that is capable of running multiple architectures that do not necessarily all look the same. So we have this set of underlying resources in this blue layer that we want to exploit in a programmatic way in order to customize network services as it is required for subscriber groups or from vertical companies. And this is what has been stated in terms of high-level requirements in the NGMN white paper. So in that sense, it's of course a business-centric view on network slicing, but in the end, of course, we need to deliver the technical instruments and we need to define the proper architecture to support this. And of course, from the 5G NORMA perspective, the lower two layers, and in particular the green one, so all these enablement, so the tools to design customized networks and to deploy and operate them, this is of course the key thing we are looking at. And of course we also try to push that, which you could also see from this morning's presentation given by Mark. We try to push this as much as possible into the radio access network. So, but of course this requires continuous effort. So 5G NORMA as such is built on three basic innovative enablers, which I listed on the right-hand side. So this is this notion of also what we saw in the morning for the radio access network, the decomposition of functions, of mobile network functions into smaller, into more fine granular blocks. And then of course we want to basically play around with the deployment and also the recomposition of these blocks. And so this is this increased flexibility that we always talk about. And this then, of course, depending on the way we decompose, of course, one aspect is the RAN versus core, but the other view, of course, is also C and U plane split. And then, of course, as I said, the finer granularity. So these are the kind of dimensions we are having a look at. Then, after, say, selecting the proper fine-grained functions, we of course have then a set of fine-grained functions that we can then of course jointly optimize depending on whether they are deployed closer to the edge or in the core network, or so the central cloud as it is sometimes referred to in this more software-centric terminology. But also, I mean, depending on the kind of groups of functions that you build. And the last point is the concept of software-defined mobile network control, which should allow for a programmable user and control plane in order to build the customized mobile network functionality that we need depending on the use case. And of course, this directly ties into network slicing. But I will come to this later. And then I listed three brief examples about what kind of flexibility this creates. So in the end, however, However, the key thing is that we want to achieve a network that's capable of delivering multi-service, or an architecture that is capable of delivering multi-service and multi-tenant networks. So we do not want to deploy dedicated infrastructures per use case or per service that we want to address, but we want to run multiple services on top of the same infrastructure. And this is all about multi-service capability and multi-tenant capability. And of course, virtualization is one key enabler for this, but as we all know, we cannot, virtualization is available in some areas, in some domains of the mobile network, but definitely not in all. So by building these logically isolated mobile networks, also referred to as network slices, so but I actually rather prefer to use this other term, so the logically self-contained mobile network instances. We want to, of course, deliver service quality and performance dedicated or customized to the use case, service-specific functionality, and of course, we need to adapt according to what kind of infrastructure, underlying infrastructure is available. And these 5 notions then basically, so it's 3 enabling innovations and 2 more, so the first 3 are enabling innovations, and the fourth and the fifth one are rather, say, result-driven or innovative characteristics of our network. This needs to be built into our architecture right from the design. So the first thing that we came up with is the fact actually that we have to have a look at the architecture and also the infrastructure in different views. So because each of these innovative enablers and functionalities actually shows some specific innovation, and depending on how you look at the architecture or the available infrastructure, these come up or are reflected in a different way. So therefore we introduce these kind of 4 views on the architecture, so which is especially, I mean, the functional view. I will go into more detail with that later. We have the deployment view, where we see where functions can be deployed, showing also highlighting the flexibility in terms of the functional deployment. The topological view gives us an overview of the kind of hardware topology that's available in different networks of different operators, and to what extent, of course, deployment view needs to adapt to the topology that's available. And then, of course, we have the resource view that sort of shows what kind of hardware and software resources are available to build such a network slice. So, when starting the project, of course, the key question was, what should a 5G architecture look like? And we all know the efforts that have been done in 3GPP, but also at the NFV with respect to the kind of management architecture, orchestration architecture that's underway. And so this is the classic figure, you know, with the orchestration and lifecycle management entities on the right-hand side in yellow, and then the classic OAM domain with the operating support system and the element management entities on the left-hand side, and then the underlying control and data plane say architecture. So in this figure I deliberately did not put any specific function. So of course, if you see these VNFs, you can easily put an MME here, an HSS, or an eNode B, whatever, or even more fine granular functions. But the fact actually is that the first step for 5G NORMA was we want to manage, orchestrate, and control mobile network instances that basically can have any architecture. So we do not really care whether an HSS is part of any network architecture, or whether we have some more lightweight, say non-3GPP subscriber database, or whatever mobility management looks like. So the 5G NORMA ecosystem, if you want to say so, should be able to support, so deploy and operate any kind of network architecture in the CNU plane, or control and data layer. So of course, This obviously is not sufficient. So the first thing we thought about, or we from a conceptual point of view, realized that we need some additional interface towards the what we call service layer, which holds application and services, according services. So end user services, if you want to say so, and of course everything that's related to business support systems and policy frameworks. And of course, these days we have a lot of talk about the companies from vertical sectors. They would also go into this service layer. So the kind of service management entity we introduced here as a first step is also serves as an interface towards this domain in order to break down high-level key quality indicators for networks that need to be deployed on the C&U layer, or C and controller data layer, and to specify this. And the service management entity then also, of course, needs to fulfill the role of mapping this to key performance indicators and, of course, to appropriate blueprints for network slices, as NGMN called this. So what kind of functions need to be included in the particular mobile network instance that's supposed to be deployed and fulfill a given service. And also, what are, if we deploy multiple ones, I will come to this in a second, what is the prioritization among those? So that's, say, the first kind of entity that definitely goes beyond what is state-of-the-art in a certain way, and which also serves, as I put it, as an umbrella function. Then the second thing that we immediately became aware of is, of course, this notion of, like for example, the TM forum talks about management control continuum. And what is behind there is basically this notion of the blurring border between management and control of mobile networks. But on the other hand, also this concept of network programmability. So how can we make our networks more flexible, and how can we change them in different time orders, basically? So in order to do more frequent modifications to the network architecture, or to the mobile network instance. And of course, there we obviously came across software-defined networking. And basically what we did, we extended this to software-defined mobile network control, this SDM-C, and introduced also an according function labeled software-defined mobile network controller, which you see right in the middle of this figure. It's here put in the control layer, but actually it's also, to some extent, it also fulfills management plane tasks, but at higher time cycles, or at higher frequencies. What is done here, of course, besides extending the class, or besides incorporating the typical SDN task, so the classical SDN, we also define this entity as a means to basically abstract from underlying network functions in general and to make them programmable via a southbound interface. On top of the SDM controller, we have defined several control applications that basically contain the logic or the intelligence for programming the underlying network functions. So this is still quite generic as a concept, but then we have applied this to different use cases, obviously. So we have talked about examples for mapping of QoS requirements into a network function configuration, for example. Also, for example, ICIC. So we have concepts and implementations for showing that, how it can be controlled by a central entity, and also then, of course, steering or controlling the network function that in the end executes or implements these configurations. So this is the second aspect, which I also will talk in a bit more detail about later. But then, of course, we have this notion of network slicing. So as you can see, we're still talking about only one network instance that is visible here. So then in this next iteration, then we brought up this notion then of dedicated. So dedicated meaning this is a function, a dedicated function for a network slice. Only one network slice uses or owns, if you want to say so, this function. And on the other hand, we have these common control and data layer functions, which of course typically could be monolithic E-node-Bs, talking LTE, or if we're talking about more decomposed RAN functionality, as presented by Mark this morning, it would at least be like schedulers, or, and of course also in a certain way the spectrum resources, if they're supposed to be shared. This is then a notion of differentiating between these two between these two categories. For this purpose, we introduced in a special SDM-C, which we labeled Software-Defined Mobile Network Coordinator, and the whole sense of it is to actually show that, or have the capability to prioritize between different network slices that use the same set of resources or network functions that are available in the mobile network. The logic then basically is that we have a set of dedicated control and data layer functions that is supposed to be controlled by the SDM-C via the southbound interface, and similar for the SDM-X that controls the share functions. Now, on top of these two entities, you can imagine all kinds of control applications. Meaning, of course, we have these classic entities like element managers that configure the network functions, and of course would then propagate these configurations through the SDM-X. And we have, for example, orchestration entities. I will also come to this in a second. So you might have realized we called it Software-Defined Mobile Network Orchestrator. I will come to this notion to the concept of this entity in a second. So what then the service management does would be to actually, from the bottom there, manage or have this end-to-end view of a network slice, meaning that it is aware of what kind of physical and virtualized network functions are part of a given network slice, which entities those BNFs and PNFs need to be delegated to for management, orchestration and control, but also injecting policies for sharing, for example, into the according control entities like the SDM-X or the according applications, which I didn't show in this figure. Okay, so I mean, with this simple example that I put here, if we have, for example, two kind of services, or in this case simple service function chains that should be deployed, you can see that we have some shared components or functions and some dedicated, and the point would actually be that a shared function would then be placed into this, say, leg of the architecture and would be controlled accordingly. The key point here is that the appropriate interfaces then, so especially then between the SDM-C and the SDM-X. So in SDM-C we would have one instance per network slice controlling the network functions that are part of this network slice, and would then also request resources with the software-defined mobile network coordinator, so the SDM-X, to compose basically an end-to-end network slice, and then you would have this, in this simple example, a chain from ABC all to the way to D, and this D would then be shared. And the SDM-X would then basically contain the policies and rules in order to enforce the proper sharing mechanisms among those two chains in this example. Now, if we have a look at the SDM-O in the upper part of the figure, this slightly goes beyond what ETSI NFV has defined for the network orchestrator, in the sense that we have, on the one hand, a decoupling of resource orchestration and service orchestration. So we have the service, meaning the set of composed functions. So we have a network slice being or containing a set of functions, of network functions. And on the other hand, we have the underlying resources. I mean, if we talk about VNFs, of course, this is general resources from the NFV infrastructure, but also, of course, when we rather think about physical network functions, so those functions where we have a tight coupling between hardware and software, also for the for a base station, for example, again. Now, especially for the virtualized resources, then we decouple the service orchestration from the resource orchestration, meaning that the service orchestrator is basically only aware of the service logic and not of the underlying resources and the resource consumption, utilization, and so on. So what then needs to be done, obviously, is, if you for a moment forget about the yellow box, that we need to map the functions that should be part of a network instance. We need to map them to the proper resources in the infrastructure. This is basically what is done by the resource orchestrators in conjunction with the infrastructure managers, which are below there. And since we want to introduce this notion of a multi-tenant or multi-service capable architecture, of course we also need to sort of arbitrate between different tenants or slices. And now this you can place in different parts of the architecture. We have one solution where this is basically put on top of these resource orchestrators that manage the resources from their respective domains here. So you can think, for example, of two different independent infrastructure providers. And then this yellow box would actually then program resources between network slices where it makes sense. Of course, depending on the kind of SLAs that have been agreed, or depending on the current resource requirements or QoS requirements from the different services. So that's one option where you could place this. Alternatively, you could put this, actually I just put the yellow boxes now, you could place this in the enforcement of these sharing policies and also of course then the enforcement of the prioritization between network slices into the infrastructure management entities. This would mean that somewhere, usually from the service management layer, you would have an injection of the rules, the prioritization rules, into the infrastructure management components, and they could then enforce those rules during operation. So if say a critical MTC type of slice has a higher priority than a massive machine type communication slice, and then the infrastructure management entities could actually enforce then these kind of rules. So that's the second option we will evaluate basically. Now, coming a bit closer to this, so this is still a very much management and orchestration centric view that I just have shown so far. Now let's going a bit deeper into the control layer actually. So the SDM-C concept, which is really the extending SDN to the mobile network domain and to all functions in the mobile network domain where it makes sense, and which also serves as the major means in 5G NORMA to achieve network programmability. We have defined a couple of functions or categories, let's say, where this is applicable to. So the first thing, if you have a look at the figure on the right hand side, of course we have basically we call it SDN aware devices. It's for example V switches, or so this would be the classic SDN part, which is part of the scope of the SDM-C. And the second, more interesting definitely and more innovative, is the second blue box. So we by means of this interface B, we configure or control physical and virtual network functions. So basically, we modify the behavior of the network function. Can be the scheduler, can be the for example, if we're talking LTE again and EPS, can be the mobility management paradigm or method that can be changed according to the requirements of the service. And this, of course, then goes way beyond what the classical SDN is doing so far. So a concrete example will also be given in tomorrow's talk, where we have some examples how ICIC, so inter-cell interference coordination, can be implemented by means of such an SDM-C concept, and by accordingly configuring or controlling the network function via this interface B. And the third part is, of course, the SDM-X, so as I said, the controller for those shared network functions. Okay, and then on top of that, you can see the control applications, again, which can basically come from different domains. So as I already explained earlier, we have these entities, functional blocks from the management and orchestration layer that sort of configure or use the SDM controller as a means to configure the underlying network functions. We can have applications for example, from the tenant domain, so outside of the administrative domain of the mobile network operator. And then we also can think of specific examples that are part of the legacy C-plane of a mobile network instance, or mobile network in general. So like QoS, QoE management can be mobility management, can be session management, can be connectivity management. So this would then be another example application on top of the SDM controller. As I said, but I guess we will have more details on that. One aspect is or one example would be QoS, QoE management, where the intelligence or the logic sits on top of the northbound interface of the SDM-C, and depending on QoS policies and requirements as specified by the service, we can do pre-scheduling, we can do enhanced ICIC, or of course the plain routing, multipath routing, for example. And the time scale that we envision for this, in general, for the controller would be in the order of a couple of tens, so a couple of tens of milliseconds. I can maybe, I think I do not have to go because most of what is in here I already talked about. This basically shows again why we actually need this SDM-X component in a little bit more detail. So it's, of course, it's specifically about the physical network functions that where we have this tight coupling between the hardware and the software logic that runs on top of this hardware. And usually we are talking about base stations, but of course this can also be dedicated hardware that is used for some specific purpose. I mean, if you think about, we still have this notion of physical network functions when we have hardware that has specific, that incorporates specific acceleration technologies, where we do not really have this decoupling into hardware and software part, as proposed by NFV. And for all those kinds of resources, in the mobile network architecture, we need this SDM-X entity. And as you can see, then the SDM-C would then also sit on top of this SDM-X as a control application, basically, and basically request certain resources or whatever functions or function configurations. And the SDM-X would then arbitrate between different requests and would do the policy or sharing, the sharing policy enforcement for those shared functions. And in the end, this means that the SDM-C concept is extended to network. Briefly skip that one. So this is for the architecture. As you can see, it's quite heavy on the management, orchestration, and control part. But this is, of course, also intentionally the case, since we really want to allow for instantiating, so deploying and operating different mobile network architectures, different network slices with their own architecture, use case specific. And but 5G NORMA will also elaborate on typical C and data layer, so control and data layer architectures for given use cases, be it enhanced mobile broadband or CMTC or UMTC. So this is certainly within the scope of 5G NORMA and part of the upcoming work. Now, another aspect that I want to highlight is the kind of involvement and stakeholder roles that the 5G NORMA architecture enables. So, as you know from for example, from the NFV efforts, we have this grouping into, to a large extent, say 2 roles or 3 if you include the subscriber. We have an infrastructure provider that offers infrastructure as a service, and on top of that we have some service provider, or also called tenant, usually something like a mobile network operator that would then use these resources and provide a certain telecommunication service to the subscribers. In 5G NORMA we have extended that and introduced this explicitly role, or I'd say redefined this role of the tenant. So we still have the telecommunication service provider plus the infrastructure provider. So a tier 1, a typical MNO, would include those 2 roles, the blue and the red one. And a tenant would be, for example, again, a company from a vertical sector that would, of course, then request a certain mobile network instance with the MNO to be deployed for its own customers, subscribers. So that's the sort of extension. And technologically speaking, we need to enable with the appropriate interfaces this setup, and also need to identify and design then the appropriate interfaces that allow for the right degree of customization by the tenant, that allows the telecommunication service provider to accordingly program the network infrastructure to deploy multiple network instances on top of the same infrastructure, but that can be, of course, separated into different administrative domains. So I will not go into great detail here. The slides are available anyway later. What we have done, we have defined a couple of service types, basically showing what kind of different involvement of the tenant is possible with respect to the customization, but also the operation of the mobile network service. So from a very simple scenario and also still I would assume a very typical scenario where the mobile network operator runs a logical network instance on behalf of the tenant. So this is a very simple setup. There is only limited interaction with the service layer and the according vertical tenant that would be active there, which is indicated here in blue, so meaning that the operation of the different functions is in the hand or under the responsibility of the mobile network operator. So this is, of course, a very simple or fairly simple scenario, because everything is in one administrative domain. Extending this towards this not so novel notion of having independent infrastructure providers that especially, of course, host and also own and operate data centers where core network instances could be deployed, indicated here in red, which would already contain some more cross-domain or inter-domain interfaces. So we have the administrative domain of the infrastructure provider, we have the administrative domain of the mobile network operator, and then we have the administrative domain of the tenant. And then, of course, more a more complex scenario, which also needs to be covered and supported by the 5G, by a novel 5G architecture, is the notion of having infrastructure providers as independent administrative domains, but also basically tenants providing their own network function, and to some extent, of course, running the network on their own. So they would not only be active on the service layer, but they would also to some extent manage, orchestrate their mobile network instance, and also then, of course, control the according network functions that sit on the control and data layer. And this, of course, immediately brings a lot of complexity into the picture, since we have a lot of interfaces that have to be designed in a cross-domain manner. So we showed this here with these dark blue bars. And also, of course, we have a lot of entities that are managed or that are available with multiple instances. So if you think about the example that you have some network functions and the according software images and so on that are provided by the tenant and that are, of course, certified against the capabilities of the M&O infrastructure. And then we have also the SDM-C and control applications that are operated by the network tenant. We have to consider that this, of course, needs to be interoperable with the left-hand side, where we have shared functions and where we need to reserve the according resources. And this is then basically going all the way from the management layer all the way down to the control layer, where we need to have the right interface configurations with, also of course with AAA, so authentication, authorization means to do a proper control of these requests. And of course the same applies into the red domain, so the infrastructure domain. Okay. Having said this, we also have a couple of novel ideas with respect to security. So the issue of bringing multiple services or even multiple tenants on top of the same infrastructure is prone to some security threats, obviously. So 5G NORMA does not aim at providing a full set of security solutions for the full 5G mobile network architecture, but the target is really to have a look at the 5G NORMA specific problems that we identify, I should rather say challenges that we have identified, and to provide specific solutions there. So we do not have a look into, say, isolation requirements in virtualized infrastructures or in data centers, because this is something that is tackled in other projects, but we really have a look at the 5G NORMA specific security challenges. And one thing actually that is very obvious to have a look at, the colleagues from King's College are in the driver's seat here, is to have a virtual unified AAA system. So we have, at the moment, we have a completely different authentication and authorization systems in the 3GPP domain and at the NF3 domain, but also if you think about the authentication implementations for in Wi-Fi, for example, EAP. So we're working on unifying this into a single AAA system. So the challenge clearly here is how to define the proper authentication mechanisms, to do it, whether to do it role-based or whether to do it rather context-based, so there are also approaches to do a context-based AAA approach. So this is one thing we're investigating. And then of course, the second bullet I put here, we have a completely new dimension that is involved now. We have the classic subscriber authentication and authorization that we need to do. And additionally, we have new customers. I mean, by intention, the operators are looking for novel, for new customers, new business models. But also this has an impact on the on AAA systems. So when we have these sort of tenants that we have defined, so vertical customers using some to a greater or lesser extent the architecture and the infrastructure that's available, we also need to define a AAA system against or for those vertical tenants. So that's the second dimension here and the second major challenge. So the colleagues from King's College have, now again talking about the subscriber-centric AAA, have come up with a geolocation database approach where we have a distributed AAA system where you have, as you can see on the right-hand figure, different slaves that permanently synchronize with the server, and these AAA servers are basically then independent of the underlying technology, so independent of the radio access technology, independent of the say UE class. So it's completely, the goal is to design it in a completely technology agnostic way, so that we really have a unified AAA system. Now highlighting two specific things actually in the RAN. First of all, boiling this down to the RAN, this of course has some implications. So the threats that obviously arise here, again, as I pointed out, is a multi-tenancy. We have multiple stakeholders that are active in the infrastructure. We want to properly separate the subscribers from each other. We have a varying degrees of isolation between network slices, and this results in new challenges for the design of RAN security, and especially the key management system for the access stratum. So what the colleagues in Nokia have worked on is a new concept for a basic key hierarchy that supports different, or that can provide different characteristics. So we can, for example, easily relocate security termination points. We can easily support multi-connectivity and also differentiate between the security of different radio legs, as shown by Mark earlier. So if we have, like, for example, one leg using the 1 millimeter wave access point and the other one uses the macro cell. So basically this means having a higher granularity. And then of course having some network slice specific encryption and integrity protection mechanisms. So that's one thing, so having this sort of technology agnostic key management and a key hierarchy. And the other thing is, of course, to have a look at the performance of key management and key generation in general and key design. So the second aspect then here is to design crypto algorithms, so keys that, for example, are particularly intelligent when, or particularly address requirements in terms of energy efficiency. So sacrificing to some extent on the key security for improved energy efficiency, or for example for improved latency. So this is another aspect that we are looking at. So giving a concrete example here, if we have a look at the access stratum security architecture that 5G NORMA has in mind, you can see that more or less like in LTE, we have the AKA procedure where we derive the authentication and key agreement on both the UE side and the network side. And from this then, so this generates this access stratum key, and from this then we can derive different additional keys. This does not have to mean that we go with the same AKA procedure as in LTE, but it will probably be something similar, and it will serve as the key root, the root for all the keys that need to be derived from that. So, of course, first thing is to have integrity protection and encryption for the C plane, for the control layer, as we call it in 5G NORMA. And then on top of that, then we also introduce integrity and encryption for different U planes. So as you saw in the morning presentation, we can have multiple U plane legs. Talking about multi-connectivity, so then we can have different keys or key pairs, integrity and encryption, per U-plane leg, and also we can basically refresh keys more easily when we have, when we, for example, need to relocate a security function due to handover, for example, or for if a service is moved, or if you think about the notion of switching a certain service to a different radio leg, so then we can easily generate a new key per session without interrupting or without interfering with already existing keys. And of course, this can be done at different granularity levels, so we can have specific key generation per slice, per network slice. You can do certain things per session, but you can also do it per on a UE, per UE level. So this kind of flexibility is inherently in this concept. So as you can see, this is pretty much close to the or an evolvement, let's say, of the 3GPP security architecture. So the next steps would then, of course, also include how to make this, or how to extend this to make it also fit to what has been defined in ETSI-NFV in terms of security architecture, but also how to extend or make it compatible rather to the other dimensions I mentioned briefly before. So also for tenant security, for example, so, and also to allow the tenants to have some own security set up here and to make it compatible to possible security systems that are available at the tenant's facility. So you can, like, if you think of a company like Bosch or something, they have their own infrastructure, local infrastructure, and have own security mechanisms in place in order to allow devices, be it sensors or robots, whatever, to register with their local network, to make it compatible also with these kind of systems. So to some extent, this means that we have to get away from the 3GPP-centric view and also accommodate other regimes in terms of the security logic, AAA logic that's employed. Okay, with this, I guess I want to close my talk, but before we get to the question part, I still want to acknowledge that this is joint work. So the presentation now was done by me from Nokia, but we have a couple of other partners. I guess this was already mentioned before within the project, and we have this work here on the architecture is of course a joint effort and a joint outcome of all those partners involved in the according work streams. So also thanks to them. Okay, and with this I would like to close my talk and
Right, I think I have a couple of minutes for questions, if there are any.
The UE security and a tenant. No, previous one. This one.
Yeah.
Okay. So you say subscribers entry, AAA, and tenants entry.
Yeah.
Tenants entry, AAA. What? I didn't really get it, to be honest.
Okay. Yeah, sorry for maybe not making this very clear during my talk. So the one thing is we need to authenticate and authorize the classic UEs, so the mobile network subscribers, when they register with the mobile network. So that's this one dimension. And as a second part, and that's more or less independent of authenticating subscribers, is to authenticate tenants or basically those new type of customers that the operators think of that request and also modify network instances or network slices that run on the infrastructure. So if you imagine an example that when we go back to one of the examples here, like we have some company, like as I said, Bosch for example, that to some extent also run and operate their own network functions on top of the infrastructure that's owned maybe by the mobile network operator. Then we also need to have proper authentication means so that the tenant can do the modifications in each of those network functions that are affected.
Okay, but I see two different levels. So one is the tenant and also mobile network operator, so
yes.
who owns the part of the network somehow. And second one is user, and then the user can belong to a tenant or can belong to the mobile network operator. So, but I see two different.
Yeah, that's what I said earlier. It's almost, I would say, completely decoupled. But it's still, I mean, it's still part of the security design in the 5G NORMA architecture. So we need to think about authenticating and authorizing subscribers, but also we need to do the same for tenants and for even if you think about this kind of interface here between if you have an independent infrastructure provider that manages a data center and the MNO only, the mobile network operator only leases or rents these resources but still needs to or controls them to some extent only, then we need to define the proper authentication and authorization needs to allow for this.
Another question, why do you have the geographical view?
You mean here for the... Yeah, that's actually a good point. So the key notion here is that we have a distributed AAA system. This is actually to allow for some location-specific handling of the security and also of the security means of the authentication and authorization mechanisms per UE basically. So the colleagues from King's College are working on a concept that would then allow to handle different regions, as they call it here, differently in terms of the authentication and authorization procedure. Yeah, the UE moves, of course, but this would be then yet another dimension. And the other thing is simply for scaling reasons. So that we have a distributed implementation in order to improve the scaling of the AAA procedures. So basically, you also have this information available locally. But I guess I can also refer you to Stan, who should also be in the room. Yes, he can also probably give you some more information, since he's the task leader and also the main head behind this concept here.
I have two questions. Also the first question is, in one of your first slides, you indicated that control plane function of the core network should be optionally could be also located into the edge cloud or into the more run part. Yes. Did you investigate is this really needed? Because we have to be aware that I guess I'm not a core network expert, but I guess that you need to some common databases, you need access, and this means you have to extend your star MME interface there, and therefore is this really needed due to latency reasons in the control plane? area, or does this bring a benefit? This is my question.
Yeah, this is actually a good point. So we have done some analysis on that, and you're right that typically we are talking about centralization of C-plane usually.
The C-plane from the core network.
Yes, exactly. And then, like I mean, it could make sense, for example, for dedicated service types, for example, to shift the mobility management into the RAN, for example. In some use cases, this could make sense. Or also, if you think about other scenarios where you want to have a local, where you also want to have basically a local core network functionality due to latency reasons, for example, then this would mean that you could also shift certain functions to the edge network or to the edge cloud, so closer to the radio access. But we did not really evaluate this in terms of, or in a quantitative manner. So we only did some qualitative analysis on that.
I think this something should be done if it is worth to do this, because of course this brings implications on the interface there as well. You have it already for the user plane function, but here I see this could bring some improvements in the latency area, but this is really needed in the control plane. This is my question. Okay, my second question is, I have a little bit the impression that this control architecture is a little bit complicated, right? Do you see here some ways, or maybe that this could be simplified? Because somewhere you have a little bit the impression that the controller, they are busy themselves to interface themselves there in such a structure. I want to put this provocative question.
No, also this is a good point, and I can also assure you you're not the first one who's raising that exactly this point.
So one example is when you're looking here, you have this element manager with the OSS. This looks for me like a little bit like a synthesis of old things with new things. And is there not anything which could be more combined to have? I'm not doubting about the functionalities which are inside, but maybe think about if it could be more summarized to fewer entities with fewer interfaces.
I mean, this is another view of showing the functional architecture of the 5G NORMA, and here, of course, you can see that we really try to put as much as possible into the control application box. So you could even say that this, like as you said, this element manager only stands for a certain functionality, but not for the legacy entity anymore. But there will be some similar functionality in 5G networks. What is there as an element manager in 4G networks? The optimum case would really be, I totally agree with you, if we could put all of this into basically into the C plane and make it a control application, full stop. So, but I'm a bit doubtful that this will work for everything, and also whether it's the proper solution in terms of accommodating or properly integrating with legacy networks. So that was one of our main considerations why we did it in the way we did it.
Maybe one comment I had also when you talk about reorchestration, that you put this always on top. Could this not be more locally done in the edge cloud to do a reorchestration and not always put it up to the bottom and then back again? And just some thoughts.
Yeah, again, totally right. And this is actually, again, if you, so if we talk about where certain things take place, so especially take the orchestration is a good example. So yes, this is just a functional view, but this does not mean that this immediately maps to a certain deployment. And this does not only apply for the data layer and control layer functions, but also we could have some local orchestration entities that are deployed locally and orchestrate resources in a particular edge data center or whatever you want to call it. And Meaning that or the fact that we only put one box here does not mean that it is completely centralized. So we could also execute this locally.
You have not shown this deployment view.
Yeah.
I think this is in your slide set.
Yeah, you're right. This is good. Could easily have this, that you say you have different, so we briefly, we had this acronym of management and orchestration functions, so MANO functions, and they could also run very well in an edge cloud, right, at the base station, and do some local orchestration.
Yeah. We'll analyze this.
Yeah.
All right. You can last one.
It's about the security. You say that the security is based on 3GPP AK. That means that the user IDs are managed by a SIM card?
Yeah, as I said, thanks for raising this point. The initial concept for the key hierarchy in the radio access network is focused on the 3GPP approach, or the 3GPP say domain. But as I said, also we will extend this towards other domains, which also will lead to the question: what is the unique identifier for UE? Will it be the SIM card in the end, or will it be also some other means? And this is something we investigate, yes. So, but I cannot give you an answer as of now. But we see the need to extend this in order to make it compatible to other kind of identification mechanisms. Yeah.
Because you have to manage also the IDs, permanent IDs and temporary IDs also.
Yeah.
And some devices have to, if you using AK, you have to somehow keep the share secret between AAA and UE, and also all the algorithms for the encryption and so on.
Yeah, exactly. I mean, I guess you're very well aware of it. There are different approaches on how you can integrate this. We are aware that we're not the first ones looking into this integration of different security domains or authentication approaches. So we will see how far we get. So that's the only thing I can tell you at this point in time.
Okay, then let us, Christian, thank you again. Next presentation is given by Alejandro Arban.